So today we will discuss about the OOPS fundamentals. What is OOPS? You can say that the OOP is standing for the object oriented programming. It is required for the faster and easier access for the programming. OOP provides the clear structure of the program, and that is the reason why it helps. You can say that you can do the dry run. And what is dry run? It means don't repeat yourself. Make the code easier, maintain, modify and debugging. And don't repeat the code. You just need to write the one time one code and that you can reuse it. That is the main fundamental of the OOPS. We can say that the OOP makes it possible to create the full reusable application with less code and shorter development time. So whenever you are talking about the OOPS, people are talking about the class and object. You can first start with the class and object. What is a class and what is object? We can say that the class is the logical entity, while you can say object is the physical entity. You can say object is representing the class. For example, if you consider the example of the fruit, then fruit is a class, then which fruit is an object? So which fruit? For example, apple. So apple is an object. If you are talking about which fruit, for example, banana, then banana is an object. Mango is an object. Suppose if you are talking about a car, then which car is an object? If car is a class, then Baleno is an object. Ertiga is an object. You can say OD is an object. But if you talk about the cricketer, then which cricketer? For example, Virat is a cricketer. Yes. So you can say Virat is an object. Saurav is an object. Sachin is an object. Now suppose if you talk about the university, then which university? Atmiya University is an object. Saurashtra University is an object. GTU is an object. Suppose if you talk about the pen is a class, then which pen is an object? I have a cello pen, then cello is an object. And if I have the Reynolds pen, then you can say Reynolds is an object. Suppose if you talk about the bank, then which bank? SBI is a bank. So you can say SBI is an object. Axis is an object. HDFC is an object. And bank is a class. In short, you can say class is a logical entity while object is the physical entity. And object is representing the class. For example, here you can talk that the Sachin is a cricketer. So you can say object is representing the class. Suppose if you talk about the Atmiya, then Atmiya is a university. So you can say Atmiya is representing the university. Right? Here you can say apple is a fruit. So there is a relationship or has a relationship between the class and objects. Whenever you talk about the OOPS fundamental, people are much talk about the polymorphism, abstraction, encapsulation, inheritance. Then what all these things are? You can say polymorphism is what? If one task is performed in the different way, it is known as a polymorphism. Poly means it's a Greek word. It means one name with the different form. So what it is? For example, suppose if you says that the animal is speaking something. For example, cat is speaking like meow. Dog is barking. Lion is roaring. But ultimately all are speaking. So you can say one task but with the different ways. So that is known as a polymorphism. In Java, we can use the method overloading and overriding to achieve the polymorphism. Let me give you the example for the same. Suppose I am declaring here one class and that class is, for example, person. Now I am writing here that each and every person has person code. Each and every person has person name and each and every person has gender. So I'm just writing here character gen. Here we can mention that the M for male, F for female and O for others. Let me save this program as opdemo1.java. Let me create here one class and that is opdemo1. Let me write here function main. This is public static void main. Here you can define the constructor to get the data. So I'm just writing here one constructor that is person. And here you can write integer person code, string person name, and you can write character gender. Here you can initialize your own instance using this dot p code is equal to, and you can get the p code that is from the user. So this dot person name is equal to person name. Here you can write this dot gender is equal to gender. So my current instance variable will be initialized with the local variable that is passed in the constructor. So how we can create the object? So it is very simple. Here you can write person, and that is which person. For example, I am talking about the person, and that is, for example, Ramesh. So Ramesh is the person. Person Ramesh is equal to new person. So you can say that here Ramesh is an object. Now here you can pass the value. For example, 101 is the person code. I'm writing here, that is Ramesh is the name of the person, and gender, for example, male. Now, instead of writing the name over here, you can write simple some object name, that is P1. So you can say P1 is an object of class person. Now, suppose I want to print here the detail, and that is, suppose if I'm writing P1, then what it will display? It will call the toString function of the object class. So here we can override our own toString over here. So we can write here public string toString. It is used to represent the object into string. So we can convert this particular object, that is P1, into string. So here we can return, and that is what? Person code, some space, person name, some space, and here you can return, that is gender. So person code, person name, and gender, that you can return over here. You can save this. You can just compile over here, that is javac opdemo1.java, and you can run java opdemo1. Whenever you run this, you will get the result, that is 101 Ramesh, and he is male. Now I want that what is overloading. Overloading means whenever you have the same name with the different number of parameter, same name with the different number of argument, it is known as a overloading. That you can do with the method overloading, and that you can do with the constructor overloading also. So right now I am just doing the constructor overloading. It means that might be a chance people pass only, and that is person code and person name. So what will be the default gender? That you can define in a initializer block. So here you can write this dot person code is equal to person code. This dot person name is equal to person name. Now I want to write one more constructor in which user is passing only person code, and that is, you can say this dot person code is equal to person code. So you can say this fundamental is known as a constructor overloading, and this is known as a polymorphism. Constructor overloading is also known as a static polymorphism. Why? Because it binds at the compile time, not the runtime. Now, suppose if you are creating the three instance over here using the three different constructor. For example, if I am creating here, that is 102, and the name of the person is, for example, Mahesh, and this is the object number 2. Now I want to create one more object, and that is person P3 equal to new person, and I am passing here 103. Now I want to display three different objects. What it will display? It will return the value, but I have not initialized any default value over here. If you are not initializing the default value, then by default instance variable, if it is an integer, then it will initialize with the 0. If it is a character, then it will initialize with the space. And if it is a string, then it will initialize with the null. So here you can save this. You can compile this particular program and you can run this. You will get here that is a space. And here you are also getting the space and null. Why? Because the string is default initialization is null if it is declared as an instance variable. Now, whenever you call any constructor, before calling the constructor, you want to initialize the value. Then you can use the initializer block. this initializer block will be called every time just before the constructor is called. So if you are calling this constructor, or this constructor, whatever constructor you call, this initializer block will be called every time just before the constructor is executed. So here you can initialize that default person name is equal to Atmiya and the default gender is equal to, that is a male. You can save this and now you can compile this, and whenever you compile and run, you will get the default value over here, that is Mahesh is a male, and here you are not passing the value, then you will get the Atmiya and N. So you can say that this is the constructor overloading. Constructor overloading is known as a static polymorphism. But whenever you are doing the inheritance, then you can achieve the concept of runtime polymorphism using the overriding. You can do the overloading in method also. But this toString function is declared in a class, that is object class. It means that if you are not writing this particular function, that is toString, then also you can access the toString, and which call the toString function of the object class. If you compile this particular program and if you run this, then you will get the result like person at the rate and has code. Person at the rate and has code. Why we are getting the result like this? Because it is calling the toString function of the object class. Whenever you write the same function name with the same type signature that available in the super class that you declare in your class, that fundamental is known as a overriding. This is known as a method overriding, and this fundamental is known as a polymorphism, or you can say this is known as a runtime polymorphism. So students, there are two types of polymorphism. One is the static polymorphism, another is the runtime polymorphism. Static polymorphism you can achieve using the constructor overloading or method overloading, and runtime polymorphism you can achieve using the method overriding. But for that you need the inheritance. Here by default each and every class is a subclass of object class, and that is the reason why I can achieve here the method overriding. Suppose if you want to overload the method, then how we can do? So I want to write here, that is method overloading. So this is constructor overloading. Now I want to overload the method. For example, that function is known as a, that is void get name. Now I want to print the name of the person. So you can just simply do what? System.out.println, and you can print that the name of the person. Now you can overload this particular function with the parameter. It means if you pass the name, based on the given name you can print the name, right? So I want to take here, that is person name, and here you can say that this is the name. So this is the function you can say with no parameter. This is the function with the one parameter, and here you can overload one more get name function with the two parameter. One is the, you can say salutation, and another is the name. Whatever you provide the saluation, that I want to concatenate over here with the person name. So you can say this fundamental is known as a method overloading, and this fundamental is known as a constructor overloading. You can save this, you can compile this particular code, and you can run this. You will get the result over here, that is 101 Ramesh Mahesh, the same result that we were getting earlier. But now what is the biggest advantage? The biggest advantage is, suppose if I am calling p1.getName, then it will print the Ramesh. Suppose if I am calling p1.getName and if I am passing here the value, for example, that is a Hariom, then it will print the Hariom. And suppose if I am passing here p1.getName and writing here, that is Miss, and that is Sita. You can save this, you can compile and run your code. You will get three results. One is the get name, another is the get name by passing the name, and another is the get name with the two arguments. So you can say this fundamental is known as a method overloading. Now what is method overriding? For example, we can say that we have one more class and that class is the cricketer. And we can say each and every cricketer is a person. So what we can say? We can say here this fundamental is known as a inheritance. What is inheritance? Whatever the father have except the private member, all the features will be available in a cricketer. And one more thing, that is what available in a cricketer, and that you can say cricketer can define their own also. For example, you can say each and every cricketer has a score. Each and every cricketer has a strike rate and a number of centuries and so many things. So here I am just defining the score over here in a cricketer, and here also I am overriding the method, and that is get name. Now here I am doing what? The same functionality that is available in the parent, and that is get name function is there. The same functionality that is override by the child. Override by the child, it means the same type signature, same function name with the same type signature with the same number of argument available in the father and child both class. Then you can say it is method overriding. Now here I am doing what? I am just printing here that cricketer name is, and I am using the person name. It means cricketer is a person, and whatever the person have, that can be accessible using the cricketer class. So what is the wonderful benefit? The wonderful benefit is here you can create an instance of cricketer. C1 equal to new cricketer. And whenever you call the constructor that is default, what happens? If you call here that is a C1 dot get name, then you will get an error. Reason? This default constructor will call the default constructor of the person. Default constructor of the cricketer will call the default constructor of the person, and I have not defined the default constructor over here. So what we can do here? It is very simple, students. Whenever you want to define the constructor over here in a cricketer, you can define the constructor over here. And you can do what? You can get the 4 value, which that is integer person code, string person name, character gender, and integer score. Now what is the wonderful benefit? You can call the superclass constructor and you can pass the person code, person name, gender to super, and you can write this dot score equal to score. So now what is the benefit? You can even override the toString function over here, that is public string toString. This toString function is overriding function of the object class, and here you can return what? That is person code, some space, person name, some space. Each and every person has a gender, and here you can print the score also. So what I did the constructor, I call the constructor over here. Now what is the biggest benefit? The benefit is here you can pass the value. For example, cricketer code, for example 1001, cricketer name, for example Virat Kohli. What is the gender of the Virat? You can say male. And what is the score of Virat? For example 125. If you call C1.getName, if you print the C1, then you will be able to access the object, and that is a cricketer. You can save this. You can compile this particular code and you can run this. You will get here that the cricketer name is Virat Kohli, and you will get here the details of the Virat. What I did that here whenever you call the constructor of the cricketer, I am passing the 4 value. I am passing the 3 value to the top class, and that is person. Why? Because each and every cricketer is a person. So I am passing the code, name, and gender to superclass, and I am assigning the score to current instance. So whenever you print the instance of the cricketer, you will get the score also. And whenever you print the instance of the person, you will not get the score. So this is known as an inheritance. You can say this is method overriding. This is also a method overriding. And using method overriding, we can achieve the concept of that is runtime polymorphism. What is runtime polymorphism? Let me give the demonstration of the same here. Let me put all these things in a comment so you people can get the better idea that what is runtime polymorphism, what is dynamic method dispatch. For example, if you write here that is person P equal to new person, and if you are creating the constructor with some value, for example 104, then by default name will be what? If you call the function that is p dot get name, then the default name will be Atmiya. You can save this and you can compile and run this particular code. You will get the Atmiya over here. But suppose if this person is pointing to cricketer, suppose if this person that is P equal to new cricketer, right? And suppose I am passing the value that is 105 and I am passing here that is Rohit Sharma. I am passing the person that is gender that is male and the run is for example 264, then you can call here the same function that is p dot get name. Now you will get the Rohit Sharma. Why? Because this is known as this cricketer name is a Rohit Sharma. It means this person class can point to cricketer class runtime. You can say this fundamental is known as a runtime polymorphism. Using the instance of the father, I am accessing the property of the child, and that fundamental is known as a runtime polymorphism. So this is known as a polymorphism, and this polymorphism can be achieved in Java using overloading and overriding. So you can say that what polymorphism is, the same name with the different form. That fundamental is known as a polymorphism, and that you can achieve using the concept of overloading and overriding. Now what is abstraction? We can say that the hiding the internal details and showing the functionality is known as an abstraction. For example, suppose if you are doing the phone call, then we don't know the internal processing, but we know that we can talk. We know the functionality how to dial the call, but we don't know the internal processing. That is known as an abstraction that you can achieve in a Java using the two fundamental. One is the abstract class and another one is the interface. In abstract class, you can achieve the 0 to 100% abstraction. Why? Because abstract class may have the non-abstract implementation also. But using interface, we will always get the 100% abstraction, that is pure abstraction, just because in interface, every methods are by default public abstract. So let me give the practical demonstration of the abstraction over here in Java. Let me create the new file and let me save this program as opdemo2.java. Now I want to define here one interface, and that interface is for example bank. Now bank interface is defining one method, and that is you can say float get rate of interest. So bank has decided that each and every bank should have the rate of interest, but until and unless you define which bank, no idea what is the rate of the interest. So you can say there will be no implementation. So by default, the method you declare over here, that is public plus abstract. So we can say interface have by default the method is public abstract. Suppose if you declare here one class, and that is for example SBI, which implements bank, then you can say the SBI class how to implement the function that is rate of interest. So if you are not declaring here one function that is rate of interest, then you will get an error. Why? Because this class is following the bank interface and they have to implement the function over here. Why? Because it is declared as a abstract function. So if you save this and if you compile over here, that is javac opdemo2.java, then you will get an error over here that does not override the function that is get rate of interest. Here you need to write the public float get rate of interest. And here you can return that the rate of interest in SBI for the home loan is, for example, 7.2 F. Now here you can define one more class, and that is, you can say the class is, that is Axis. So you can say Axis is also implementing the bank interface and having the rate is, for example, 8.1. Now I want to write here one class, that is OP demo 2. Here we can define the method, and that is what public static void main. Now here we cannot create the instance of the interface. So I cannot write bank B equal to new bank. If you write here, then you will get an error. It means you can show the functionality, but you cannot implement the things using this particular interface. And that is known as an abstraction. We cannot create an instance. So what we can do? Using interface, we can point to the class. So we can write here bank B equal to new SBI, and you can get the rate of interest. So you can write here system.out.println b.get rate of interest. Even you can point to, that is bank B equal to new, and that is Axis. Now if you are pointing to SBI, then you will get the rate of interest of SBI, and if you are pointing to, that is Axis, then you will get the rate of interest of the Axis. This fundamental is known as a dynamic method dispatch, and this fundamental is known as a runtime polymorphism. You can say whenever you define interface, it is pure abstraction. Why? Because using interface, I can show the functionality only. Implementation will be done by the class. So this fundamental is known as an abstraction. You can say that this fundamental is known as a runtime polymorphism. You can do the same thing using abstract class also. Instead of this interface bank, you can declare the class abstract. But if you declare the class abstract, then might be a chance you can declare the non-abstract method also. So might be a chance, there may be a chance the abstraction from 0 to 100%. But if you are declaring interface, then it is a pure abstraction. You can say it is 100% abstraction. In interface, whatever you declare the method, by default it is a public abstract. In interface, the constants is by default final static. In interface, we cannot create the instance. In interface, we cannot write the constructor. In interface, we can write the static, default and private methods. So we can come to the conclusion that abstraction is what? Hiding the internal details and showing only the functionality. Here in our case, bank is showing only the functionality that get the rate of interest. Bank is not showing that how the interest rate is coming over here in this particular example. So we can say that we can achieve the abstraction using two concepts. One is abstract and another one is the interface. Now what is encapsulation? Encapsulation means binding the code and data together into one unit. That is known as the encapsulation. It means, suppose if you define a one class and if you define all the things inside the class, like a capsule, we can give the example that a capsule is wrapped with the different medicine. In Java, class is the example of the encapsulation. See here, I define a one class, that is OP demo 1. So you can say this class person is an encapsulation. Why? Because in this class I define the member, in this class I define the method, in this class I define the constructor. So everything you define into one single unit, that is known as a encapsulation. But what is pure encapsulation? You can say that pure encapsulation is, that is whenever you define the Java bin, that is known as a fully encapsulated class, because all the data members are private there. So let me give the example of the encapsulation. Suppose I want to create one more file, and that is opdemo3.java. Now I want to define the same class that I did earlier, that is class person. But what is the problem over here in this class person? That whenever you define a one class, that is OP demo 3, For example, if I am writing class OP demo 3, and whenever I define the main method, that is public static void main, using the instance of the person, I can change the value. For example, if I am writing person P1 equal to new person, and if I am passing the value, for example, 101, the name of the person is, for example, Ramesh, and the gender is male. Now I can print the content of object by overriding the toString function. So whenever I print P1, it will call the toString function and it will display the code name and gender. So you can save this. You can compile over here, that is Java C op demo 3.java, and you can run Java op demo 3. You will get 101 Ramesh and male. Now students, what happened whenever you are talking about the encapsulation, it means you cannot access the instance variable outside the class. For example, if I am changing here, that is p1.name, p1.person name is equal to Mahesh. Suppose if I am changing this, then I can change the name. Outside class cannot change the instance variable. You can change this by using some procedure, by using some functions. So here I can change the value, that is instead of Ramesh, it is Mahesh. So this should not be allowed. This should not be allowed. How we can do this? For this, you have to declare these variables as a private. Whenever you declare your instance variable as a private, outside class cannot access this. So I cannot change this. If I am save this and if I am compiling this, then I will get an error, pname is a private access. So I cannot change this. Now how can I change this? So for that you can define some method, and that is what you can define, that getter and setter. What is getter setter? For example, void get person name will be the function. Using this you can get the person name. So here you can write the string get name. Why? Because a string is the type of person name. So you can define here string get name and you can return the person name. Here you can write the function, that is integer get person code, and you can return the person code. Here you can write, that is character get gender, and you can return the gender. One thing. The same thing you can set the person name, set the person code, and set the gender if it is required. So you can call the function here, and that is what void set person name. And now you can get the input from the user, that string person name. So you can write this dot person name equal to person name. So explicitly user can call the function, and using function we will allow the user to change the name, but we will not allow the user to change the code. Why? Because I have not implemented the function. But if user want to change the gender, then we will allow using the function, that is a set gender. And here we will get the gender from the user, that is character gender, and we can write this dot gender is equal to gender. So what I did, I used the function, that is, you can say this function is known as a getter and setter. You can say this setter function is used for the to set the person name, and this getter is used for the get the person name. This is for the get the person code, and I'm not writing the function to set the code. Why? Because once the person code is assigned, I don't want to change the person code once it is assigned. So I will not make the setter function of the person code. And you can say this is the getter of the gender and this is the setter of the gender. So person cannot change the name directly, but person can call the function, and that is set person name, and you can write the Mahesh over here. If you save this and if you compile this particular code, then you will not get error and you will get the result, that is 101 Mahesh. In short, we can say that I'm not allowing user to change the value directly. If they want to change, then they can use my function. And inside the function, I have written the implementation. And suppose if you don't want to allow user to change something like a person code, then you cannot write the function that is set person code. So this is, you can say, get the person name, set the person name, get the gender, set the gender, and this is the get the person code. It means whenever you declare the variable as a private and whenever you write the function for the getter and setter, that fundamental is known as a Java bean. What is Java bean? Java bean means whenever you define your instance variable as a private and you define the getter and setter to get the data and to set the data, that fundamental is known as a Java bean. And Java bean is the fully encapsulated class. So here we can say person is fully encapsulated class. So I define everything inside the one single unit that is in class person, and that is code, name, gender, initializer block, function, constructor, toString, everything inside the one single class. That is known as a encapsulation. So we can say Java Bean is the fully encapsulated class because all the data members are private there. Now another OOPS fundamental is there, and that is known as an inheritance. What is inheritance? We can say that the inheritance can be defined as the process where one class acquires the properties of the another. For example, what I did earlier, I created the class cricketer which extends from the person. So we can say each and every person is a cricketer. So that is known as a inheritance. With the use of the inheritance, the information made manageable and in the hierarchy order. For example, see here in demo 1 what I did. I created the another class that is cricketer which extends from person. It is known as an inheritance. Now how I manage the hierarchy? Whenever you create the instance of the cricketer, I pass the value of the person, and that is person code, person name, and gender. Why? Because all these are the attributes of the person, and cricketer is a person. As well as I am passing here score. So you can say that this three value will be passed to the upper class, and that is person class, and this value will be used in a score. That is, this score will be used in a class cricketer. And we all know that this cricketer can access the property of the person, so we can call the constructor and toString method to get the data. Suppose if you have one more class, let me define here one more class, and that class is, that is a student. Is a student is a person? Yes, student is also a person. Now each and every student has some different attribute, and that is what you can say that student is learning in the program. So in which program student is learning? So you can say string program name. So student is learning in which program? So you can say student is learning in MCA. So here we can write string, that is program, and here we can do what? We can pass the value that is person code, name, and gender into person, and we can initialize the value that is this dot program is equal to program. And here you can just get what? The cricketer, instead of cricketer name you can get student name, and here you can, instead of score, you can get the program name. Now what is the wonderful benefit? The benefit is the same way you created the instance of the cricketer, you can create the instance of the student. So you can write here student S1 equal to new student, and for example student is having the roll number that is 2001, and the name of the student is, for example, Nirmala, and the student is female. Now learning in the program that is MCA, you can write s1.getName, and you can call the toString function of the student. Here you can pass the program name and that is MCA. You can compile this particular code OP demo 1. See here, you will get the result that student name is Nirmala, 2001 Nirmala female MCA. It means that I did the inheritance. You can say student is also a person. So in hierarchy order, I pass the person code, person name and gender in the superclass, and I keep the program name in the student class. And as a student is a child of person, can access all these strings over here. So this is what the inheritance is. So we can say that the class which inherits the property of the other is known as a subclass, that is also known as a derived or child class, and the class whose properties are inherited in other class is known as a superclass, which is also known as a base class or parent class. The example is, suppose if you are taking the Java 11, then it is inherited from Java 10. Now, what are the different keywords? You can say static. Using static, we can access directly the members of the class without creating an instance. What is this? This refers to current instance, and super refers to instance of the super class. Final means whenever you declare the variable as a final, you cannot change the value. Whenever you declare the method as a final, you cannot do the overriding. Whenever you declare the class as a final, you cannot do the inheritance. Abstract is used to promote the overriding, and using abstract we can achieve the concept of abstraction, but not 100%. If you want to retrieve the 100% abstraction, then you can use the interface, and using interface we can achieve the 100% abstraction. So that's it.